Hello. You just watched the project that we want to present to you today. It consists of a web-controlled robot.
Hope you enjoy it. Our project for today is a remote controlled robot that was built using affordable devices, including an Arduino Uno board, a Nash bridge for controlling the DC motors, and a chassis that's used as a support for all for everything, and an Android device that was used as the eye of the robot. You're gonna find the links in the description for all the devices. Also, you're gonna find the source code that we'll share included in the video description. In order to reduce the complexity of this project, we're gonna explain it in three parts. In the first part, we're gonna explain how to control a DC motor from Arduino using an H bridge. In the second part, we're gonna control four wheels using Arduino, and we're gonna send commands to this robot via an application installed in an Android device. And in the third part, we're gonna show how we can control the robot from web. In order to control a DC motor from Arduino, we're gonna need an H bridge, in this case L298N, which needs a 9-volt DC power supply in our case. This H bridge can provide us with 5-volt DC power, which can be used as a power supply for Arduino. Arduino, in turn, can provide the rotation and direction via 2 pins, and it can also specify the speed via 1 pin, PWM, and the H bridge can send this information back to the DC motor. This H bridge can power 2 DC motors via these pins. Then we can connect the power supply to these pins. Basically, we have to use 9-volt on this one. This one can be served as a ground, and this one can be served as a 5-volt output. Oops. Okay, and we're gonna use a small breadboard here to show how this actually works. Oh, already disconnected. Okay. So basically we have the ground here, 5 volt here, and we can already power our ship, and we already see that it shows that it's already taken power. So we have here 2 pins that can control the left motor, and the other ones is similar for this one. So let's take from these 2 and see how this actually works. If we connect one to neutral, the other one to 5 volt, this motor actually works for one direction. And now let's reverse the input. Now it works, and for the other direction. And this is actually what we intend to do with Arduino. Basically, if we give 1 0 and 1 1, or low high, it would turn one direction, and if we reverse it, it would turn the other direction. We can write a program to make this more this automatic. So this program contains struct, which is DC motor. It takes 3 pins, 2 pins, pin 1 and 2, for controlling the direction, and the other pin is for speed, which is an analog pin. So in the setup, we set the 3 pins mode as output. In the set speed, we make an analog write to specify the speed value. Then we have 2 methods, forward and backward. One specifies pin 1 as high, the other one as low, and to reverse, we specify the pin 1 as low and pin 2 as high. In this particular case, the wiring is that motor 1 is connected to pin 2 and 3 for direction, and 9 for speed, and motor 2 is connected in 4 and 5 for direction, and 10 for speed. Then in the setup, we set up both motors. We set one motor speed 200 and the other one in 100, and in the loop we just specify that motor 1 and motor 2 should move forward. We wait for 1 second, then both motors should move backward, and the loop should wait for 1 second. After uploading the program to the Arduino board, all we have to do now is the wiring, and we're gonna use the same setup from earlier. So we're gonna connect here the ground to the ground, and 5 volt output to Vin. Okay, for the first motor, we're gonna need to connect the first 2 pins here. To pin 2 and 3, as specified in the program. And for controlling the speed, we need to connect the enable pin, which is the last one, to pin number 9. And do the same for the other ones. Basically, use the 2 other inputs. For pin 4 and 5, then use the last pin for speed control, which is connected to 10. Alright, all we have to do now is to provide the power source. So we connect it. Okay, and now both DC motors are turning, and they take in each cycle 1 second, and one turns faster than the other, which proves that our setup actually works.